Sure. Are you class at one?
I have two questions after my calc.
That was for finding the person carbonate from the back.
11:30. Yeah, it's like 30 minutes. During this class. It's like, wow.
But then I talked about also that we can use the right.
Did you do any chores this weekend?
Hey, what?
Chores.
Or chores.
It's like duties, it's like tasks. Cause I was like, oh, you don't have to paint. And you're like, oh, I'll find some.
Yes, I was hammering metal posts
Oh,
for here and around to save trees.
gotcha.
Ah.
Some manual labor.
You guys have a lot of trees?
Yeah, we just planted a couple before, and next night they were almost bare stems.
No.
Like dozens of, no fence and dozens of deers.
Are you on the edge of the city?
Just on the river.
Oh, you're on the river? Oh, that's cool. Because
Well, weekend was good. Well, we'll go over the class materials, but think about end of semester. You will have an option to vote for a regular exam instead of project, but typically everyone was working. So we do not have enough mathematical muscles for the project, but you may think ahead what would you like to study? And basically it should be something that can be eventually projected on one dimension, probably with like barriers, right? The chemical reaction vis-a-vis activation barrier or stuff like this. We will talk more. Just start preparing a room in your brain to think about it. What did we do last week at the lab? And some of you have already submitted homework based on the lab. You might be able
to simulated probability distribution of an electron in a box.
perfect. Here is the word of your former instructor. But was it like static or was it changing over time?
It was changing over time.
Why? Does it contradict with postulates of quantum mechanics? You know, like system analysis, eigenstate never change over time. And here we see something like system prepared in its eigenstate doesn't change over time. So let's play with linguistic experts, like catchwords. System in the eigenstate never change over time.
If the state is oscillation.
Is not an eigenstate, right?
Okay.
And how to create a state which is not an eigenstate, what it is. It's childish questions, you know, much more and much deeper. I'm just trying to wake up together with you and establish connections between pieces of information. Like if phi1 is eigenstate and phi2 is an eigenstate, if you add them together, will it be an eigenstate? No. In differential equations, summation of solutions is a solution.
Yes.
Right? Or like full time dependent stuff. But if summation of eigenstates for eigenvalue problem is not an eigenstate, right? It could be a solution, but it is not an eigenstate.
Okay.
Right?
Yeah.
And the postulate, which postulate means no one cares to prove it. Then if we create a superposition of eigenstates, it will not be static, it will change over time. So the main philosophy, take home message, or take from home message. Then if you want dynamics, we need to create a superposition
Of eigenstates.
Well, if you take a random function, it technically will be an eigenstate and it will show dynamics. But if you want to add a little, how to say, control, quantification, systematization, it's better, like eigenstates is alphabet to study certain system. And then if you compose layer superposition, it will show some dynamics. The connection to real life that we want, like bouncing from the edges. But in you already saw, you did it yourself on the board, and it was different. And it will be like at least 2 meetings on this subject, maybe more.
For the time.
Wake up.
So the time independent Schrodinger equation has eigenstates,
Right.
and we made a superposition of those eigenstates and resulted in something that.
And we plug them into time-dependent Schrodinger equation as an initial condition.
Okay, so yeah.
So we should rename this class and call it, bring it from chemistry to math until applications of differential equations. You see, we have boundary conditions, we have initial conditions. I'll probably go through slides, but stop me anytime, and if I see that you are bored or if I'm getting bored, we'll return to interactive interview style. I would love to just do derivations on the board. It would be more healthy. But the arrangement of this short 50 minutes, it's enough time only for introduction, for derivations which we all can comprehend in slides. When it's like 2 lectures connected together, then one can do something slowly discussing, as we do on Wednesday. 2 hours is more optimal for, not for us as humans to not get exhausted, but to cover materials. This is our homework that some of you already submitted, some just send it by the time of the class on Wednesday. The number 5, it will be based on what we will do in the lab, and if you will see no problem, but I hope you will be positively impressed. So the if this impolite to speak while sitting too much. What is here? What do you see here? You like this diagram, you hate it, or you don't care? Answer.
Kind of both, man.
Okay, it's a you give me a best possible credit if I would be an artist. Like this masterpiece didn't let audience without reaction. Like if you love and hate it at the same time, it's
Like solid like 8 out of 10.
but what is it? What do you hate more at most? What do you like at most? What is so surprising?
I don't really know. It's just I think I'm just that tired. So woken up enough.
I'm on the same page. But what is on the X and Y axis?
That is like what we've already discussed, like how like ways to predict the future.
Good.
And then the y-axis is like the confined areas.
Okay, perfect. Yeah, thank you so much. So, I was repeating this course again and again, and I fight my own lack of organization from years, maybe not very successfully. And I noticed that this huge amount of material is not possible to carry in the head without systematization, at least an attempt. And the course material develops in opposite directions or in orthogonal directions. On one hand, we learn methods, Spencer taught us. On another, we try to apply them to realistic systems. At each little meeting or part of the meeting is a point on this diagram. So we need to have a lot of more points in the y direction and few more points in x direction. So we started, one-dimensional blocks for time-independent Schrodinger equation, and today we will focus on time-dependent Schrodinger equation, what Garrett summarized, right? And it will be connected to a new concept that will be announced a little later. So this is a summary of what we did last time. So you should be, I wouldn't expect happy, but acquainted, right? So box means there is potential energy, and it is either infinite or zero, and there are borders where it gets, and typically one does it by brackets. And then by solving boundary conditions, one is getting solution which are signs, but the wavelengths or spatial frequency of the eigenfunctions is discrete, right? It is what Anna taught us on Friday. E sub n. So E sub n and nothing else, it's already a deep sense. Quantum traffic science. You are allowed to move only with certain speed. Exactly. If you're in between, you are charged. And this is, I wouldn't say you have to memorize it in the middle of the night, but you should be not surprised seeing it, right? Do you find any grammar errors on the slide? Yes. I would be very appreciative if you find something to contribute to next generations.
I don't think so. I'm not saying anything.
Should take credit. So, are there any confusions, or we all agree that it is a noble subject to pursue for the remaining 30 minutes? And you kind of have an idea what we are going to receive, right?
Mm-hmm. Yeah, I think it makes sense.
So half excited means superposition, and then there will be some distributions in space and some will be looking at time. Okay. So why, right, like in undergraduate studies, credit, you go from year to year, accumulate some like decorations, like yes, in the instructor's own life. I don't think we need to orient. Maybe it was a why time-dependent phenomena are needed. So they reveal, even if in your academic life, in application of materials from this class to other classes, you will not explore time-dependent phenomena. By looking at them, you get into deeper understanding. Like, today's discussion with Garrett, like without looking at time dependency, one wouldn't appreciate the importance of superposition. Like superposition is needed even without time dependence, but you bringing it in, so you have the full picture. And original theory was designed as time-dependent theory. It is a simplification for like shortcuts to avoid it. So I'm standing for including it as a substantial part of it. For this, what do you see?
Like, do you want me to like say like what it represents?
Yes, or how, whatever, any comments?
So over time, the probability density is changing in position. So it's, as it moves through time, there's a higher probability density in the closer distance or the further distance.
Perfect. All agree, right? And we need to get the same result, but by pen and paper or by whatever, screen and keyboard. And this is center of this distribution, which never comes to the edges. It oscillates in the middle, and it is one of the different, and it's continuous instead of straight lines, as one would have in classical example. It's not 18, it's 17. So those are your components of the reaction, right? E sub n, as Anna knows, and then the function. And we are going to combine them in order to get the solution. So use solution for time independent as a component for time dependent equation. This is your figure 1 from the homework, right? So phi 1, phi 2. Here is how it was summarized by the bubble software. And it is a quite standard thing that if you look for basically any text on physical chemistry or quantum theory, you'll see images like this. And those images are a little violation of purity, although it is used in all books. So the y-axis is simultaneously an energy and probability distribution or wave function, right? So one compares apples and oranges right away. But it just summarizes things on a one panel at the same time. So one has energy offset and one has like, meaning I do not put label because what to put? Energy plus probability, like apples plus oranges. And if instead of wave function, one puts square of the wave function, it looks like according in respect to average line, it goes only to positive side. Right? So those are, well, one can tell like probability plus energy. Okay. So why there are 1 over square root of 2 here and there? Was not speaking yet.
Question for me?
Say anything.
Huh?
Say anything.
Say anything about this slide?
About the circles.
About the circles.
Do they surprise you? Are you happy?
I'm so happy.
Accept the correct answer. So we to save space and notation, one replaces the wave functions by this angular brackets in Dirac notation. But the coefficients C1 and C2, why are they 1 over square root of 2? It's all set up problem for quicker education, but why these numbers?
I'm trying to remember back to our.
No. It's a free country, everyone does what he wants, but I share only my personal opinion.
Okay.
I'm telling to myself, I'm not instructing or pushing Dmitry, avoid remembering, switch off your memory, think only. Okay?
Okay.
Do whatever you like, but what is your opinion on this? And there's nothing to remember, we never talked about it before.
Well, okay, so that looks to me like the sign of a pi over 4 triangle.
Great, how
Okay.
nice. And cosine of pi over 4.
Is the same thing.
We are on a threshold of a great discovery. Thank you. I wasn't thinking so deep, but it is correct. Okay. Sine theta over 2, sine theta over 2.
right? And now, if you go this way, what will be sine square of this angle plus sine square of this angle? What? So now let's project, if this was C1, this is C2, what will be C1 squared plus C2 squared?
1/2 plus 1/2.
I wonder what will be the result.
I don't know.
Okay, can you say it more philosophically on the language of quantum theory? Like expansion coefficient squared added together give 1. How would you call it? Now it is recommended to switch on memory. Anyone is welcome to go. Maybe just give a moral support. Go and go.
You got it.
You add,
Is it-
what would we call it?
If you add them together.
If you notice a property that like I don't know, maybe you would prefer more mathematical psi equals summation over I c sub I, right? And then you tell that psi sub I squared summation over I is equal to 1. What would be the name for this property?
I want to guess eigenstate, but I just don't know if that's right.
Let's try again.
Okay.
There was I cannot brag of good memory, but something like homework 3, problem 1, maybe 2. You have this word and it starts with letter N. Let's play Wheel of Fortune.
All right.
So why do we have this factor 1 over square root of L? The word starts with letter M.
I don't know.
Normalization.
Yes. Thank you. Thank you for this.
That was sick, Curtis.
So we do have a property that wave function must be normalized. So if you do in the continuous way, say I can draw legitimately psi squared dx should be 1, right? Normalization. If you convert this continuous into discrete, it means expansion coefficient squared added together must give 1. It is like mandated. And if you do not pursue, if you do not have this property, transition from abstract wave functions to practical observables will be very wrong. So normalized wave function is needed to secure answer for having this theory reasonable for predicting experiments, for being connected to real life. And Emma did a great discovery. She recovered that this sine and cosine squared added together will give 1, right? Which means C1 squared plus C2 squared is 1, which means this wave function is normalized. Right? So it is what we all summarize. We prepare not an arbitrary superposition, but such superposition that the initial wave function is normalized. Why 1 over square root of 2? I was so angry on authors of textbook. If you just screen through a dozen, they like this example. Superposition of 2 states. And they always start like, consider superposition with the probabilities 1 over square root of 2, 1 over square root of 2. And they do not explain. They think I have resources to analyze it on my own. I was trusting on like author of the book to guide me through little steps. So the simplest human factor in logic that we we want 50-50 distribution between ground and excited, right? But 50-50 is 1/2 and 1/2 will be for probability. And probability is wave function or wave expansion coefficient squared, right? So we need such numbers that upon being squared would give us just 50-50 distribution. So square root of 50% will be 1 over square root of 2. Make sense? Some advanced physics courses avoid this 1 over square root of 2 and they follow M away. They put sine square theta over 2, cosine square theta over 2, where theta is angle describing how far system has been promoted from ground to excited. Good eye. You noticed it. I'm proud. It's first time in 12 years. Very strong. Okay, so this is our initial state, right? 50-50. Someone already added scratches on this slide. Probably it was me. What do we see here? Spoken. I don't know. Any comments on what we see? Maybe like second line. How would you interpret it? Like you don't need. It's okay not to give the answer. Nothing. I'm not answering. But just share your thoughts. What do you like? What you do not like? What surprises? What seems natural?
See that we're doing a piece of one and use of two and we're adding them together. And so like, is that like replacing like the one? Because I see that the square root of 2 is still on the bottom.
Absolutely correct. Yes. So it is what it is. But why do we substituting one with phase accumulation factor?
So kind of like how you're explaining, like that's like how much like it's moved from like the ground state. Because like you're like explaining like the theta over 2, like so is that like how much you moved from like the ground state to the excited state?
You're right and wrong at the same time. So there is, and I'm guilty for the wrong part because I created a deception. What Emma told on the previous slide, there was a same parameter theta over 2 for both. And here we notice that there are different E1 and E2. So they evolve in time independently, right? So where it comes from? Have you seen it before? Which way? I'll give a little hint. Which number of the way which way to predict future it comes from? But okay, but tell a little bit more. Future is always time dependent, most of the time. But I don't know, maybe if I will be like turning my back to you and then writing something on the blackboard and mumbling it will be more peaceful. You okay? I take notes or just relax, you mumble whatever you like. So how many ways to predict future do you know? In context of the course.
3, is it?
Yeah, and then there was a force from Heisenberg, but it is not like evolution operator, discrete, and then number 3, what does it tell about? Oh, you're a certified expert in this method, because you got A of this homework. So for those who are actively taking differential equations, it is a solving initial condition problem, right? You were talking, well, you both were talking. Anything, any other comments? How does it connect with initial value condition problem? Or third way to predict future? I mean, you did great. You answered everything correctly. I just want us to go forward with me orchestrating and you doing the move forward. Either maybe there is a different way you would become happy about this equation. If I write psi of t equals summation over I, c sub I by sub I, e minus I over h bar, e sub I t. Is it something you remember more happily? Does it click anything? Right?
Yeah.
So third way to predict future. Now, so this will be phi sub 1. This will be phi sub 2. 1 over square root of 2 will be C2. 1 over square root will be C1. And this E minus E1, it is exactly this time-dependent factor, where energies E sub 1 and E sub 2 come from energies of eigenstates of solving time-independent equation. So we're just practicing third way to predict future, but we take initial conditions as ordered to us by Emma. 50-50. All happy? Everyone is ready to answer this question if needed, right? So it's just an application of third way to predict future for a superposition between first and excited state. But each of the states evolve forward in time, accumulates space with its own phase, with its own energy. Now we can look, we can have a glance on this subject from a little different perspective. Right now, in the line number 2, we had a expansion coefficient and time-dependent factor. But we can symbolically tell that expansion coefficient and time-dependent factor are combined into the time-dependent expansion coefficient. So, and then it will be what Anna was mentioning, how this looks like. We replace, we just multiply 1 as square root of 2 on this oscillating factor. Why are we doing it? Why are you tolerating this boring stuff? Spencer? Or you're not tolerating it anymore? What are the benefits of doing it?
Well, it just is. I'm not really sure, honestly.
But what is the goal?
The goal,
Which moving image are we getting?
we're getting that the oscillating wave.
Oh, yes, and we want to get this wave through applying principles and mathematical methods, right? So, and the only way to get it is to go through the superposition and phase accumulation. Doesn't answer? So it is the reason to tolerate this little exercise. Okay. Okay, most complicated part of today's meeting. There are much more slides, but they all will be rolling downhill after this one. So I probably would ask our previous instructor to explain this step. And you can speak a little longer as a certified instructor, and you see, everyone is going to fall asleep, right? So with jokes or explain motivation again, otherwise it will be boring, like 6 lines of equations, I will not survive, or I will drop the class, or I don't know what I will do.
So it looks like we have two size, so two wave functions. And we're representing both of them as their own superpositions. And we're multiplying those two superpositions.
Yes. So now you can ask the audience. Anyone knows what will be 2 multiplied by 2?
Does anyone know what 2 times 2 is? 4.
Now ask what would you expect? How many terms will be in the next expression?
In terms of the expression.
So you see,
Four.
like 2 here, 2 there. If you multiply them with 1, 2, 3, 4, right? Okay, let's give a tour of applaud. Guiding us through the most complicated part. Kaiden, please continue telling us about these four terms.
So each wave function is being multiplied by their complex conjugate. So the expansion coefficient from the normal wave function being multiplied by the expansion coefficient from the complex conjugate of the other wave function, as well as the 2 ket functions.
So do indices coincide or not coincide or both, or and how do you live with it? Or how do I live with it? So you see, you have first, second, and then there are, if you multiply first by first, indices coincide. Second by second, indices coincide, but first by second, second by first, it will be opposite, right? And it is nothing philosophical, it's just simple algebraic opening brackets. And those will be like wave functions also, wave function itself and the cross terms, right? What Bubble Software thinks about it. The object that we have composed is called density operator. It's never needed at this level of the class, but it doesn't mean that you don't have right to be acquainted with it. But if you take mathematical procedure of trace of this density operator, it will be just probability distribution. So now we remove this brass and cats, and we still have 2 types of terms. We have time-dependent factors and products of the wave functions. Right? Now, why do I waste my and your time? Why don't we do MATLAB 1? This is quite simple exercise for both humans and computers. On this example, we can give namings for the components of this expansion. And later on, if needed, we can apply it again and again. Or if you read or write professional literature, like publishing papers, maybe we never need this subject related, but we will have terminology and language to speak about this processes and objects. And this will be much more general than this boring little example. So for first and last, we can call it just probability distribution for wave function, but those for like density distribution. But for cross terms, it will be transition density. And the time-dependent factors, which include time-dependent expansion coefficients of both left and right wave function, are referred to as density metrics. So the stuff here is referred to as density operator, and the metrics elements, factors that control it are called density metrics. Density metrics. So time factor and space factor, right? And by adding them together, we'll get a solution. So let's, and there are two indices. If it is density matrix, it's like row 1, 1, two indices object. For this example, one doesn't need any terminology, any advanced symbols, but if there will be like 1,000 by 1,000, you're not going to pull all of them. You can just tell there is a adding together density matrix times transition density so many times as needed. And then people who read you or people whom you read understand each other. So products of functions are here. And here is another little challenge. It's like, it's less complicated than the one that was taught to us by Garrett, but it is like a two-barrier reaction. We went over highest barrier and now there is one more. So I need help, maybe of Curtis. Please try to help. So I'll explain what we need to do, and you do as much comments as you feel comfortable. So I'm going over this density matrix elements, this expansion coefficients with all possible indices, and plug in the values of C1 star, C1 without star. So I need your comment how we combine those time-dependent expansion coefficients and what we get as a result. If you want a simplified task, you can speak only about those elements where indices coincide. Just look and tell what you see.
Well, for multiplying exponentials, you can add or subtract the powers. So if you have the star and the regular one, one's positive, one's negative, so they should cancel.
Perfect. And then we have 1 over square root of 2 times 1 over square root of 2 will be 1/2. Great. Yeah, many thanks. Many thanks. Let's give a round of applause. So elements of density matrix with coinciding indices are equivalent with probability distribution, right? They are time independent, and by adding them together, like row 1, 1 plus row 2, 2 will be 1. It is the same normalization as was taught to us by Emma, right? You see, they are time independent. What a wonder. We give this long, complicated combination, but it gets time independent because time evolution forwards and backwards in time compensate each other. Everyone spoke about it 2 times. Emma, would you like to start helping us once again? It's very complicated subject.
Okay.
Just what do you plug in? What do you get? How to interpret? So I'll start, but I need help to continue. So if you look for this element, we will plug in C star 2, C1 without star. And if I plug them in, this phase accumulation factors, what do we get?
I know what Chris was saying. If you add the exponentials or the
Exponentials of the same or different?
they're different, but you can factor out the T over H bar.
Okay, and what controls the pace of time evolution of this cross term? Just explain what is in this bracket.
Difference between the energy.
Yes,
Okay.
and now let's copy paste your sentence,
Okay.
put it into ChatGPT and ask, please refine the sentence that it will read better. Or you can read on your own. Like instead of passive tense, more in active.
Okay.
So the subject will be
Okay, so P12 is dependent on the difference of energies between the two things.
Absolutely correct.
Okay.
Let's go a little deeper.
Okay.
So energy difference.
Yeah.
Let's go forward. Defines
Row 1, 2,
how rho 1, 2 depends on,
time.
okay,
Okay.
of phase accumulation, or time dependence of the off diagonal elements is controlled by energy difference between quantum states, right? Between eigenstates. Perfect. Let's apply to. So we do have time independent parts and time dependent parts, and you see, it's time. It's like delta with plus and delta with minus, right? It's just they go in forward and backward in time, but with the same pace. Yes. So we will get a useful consequence out of it. And you already did it in the lab. Maybe you, after Wednesday night, you forget everything. But if we do have two imaginary exponentials, see, there are two imaginary exponentials, and I was just minus I delta plus I delta. If you add together two imaginary exponentials that have opposite sign, whose name we remember right away? James was reminding to all of us.
Spoiler.
Yes, thank you. So what does Euler? What do we learn from him? What is the result of adding together two exponentials moving in the opposite direction? Yes, absolutely correct. So we will get rid of the imaginary stuff. Density matrix is imaginary, so it's. But if we add together, in order to obtain observable things, come back into real world, and it happens naturally. So this is what Emma and Garrett taught to us, right? So here is the phase, ground, excited, blah blah blah, dictate, time evolution. Probably you expressed it better than I could. And now we are coming to what your homework should look like, or ideally, what was it about? The spatial factors are just multiplications of this pair of eigenstates, right? So you have ground state, excited state, and then their product, which is a transition density, right? You recognize it. Now for the time dependence, with my own even logic. So when we add these things together, we get trigonometric functions, and these trigonometric functions tells us that by adding together this sine squared, cosine squared, and the product of them, so the product will come multiplied by trigonometric function. It will come either as a positive or negative. And this image, so I'm just going forward of the what we are going to get on Wednesday here. So if we add red line, blue line, and then this oscillatory dashed line will come either as a plus or as a minus. When it comes as is, with plus time dependent factor, it will contribute to make left side of red peak taller, and it will basically cancel the right side of the red peak, right? Then the overall sum will be moved, leaned toward left. When this stuff multiplied by negative, it will constructively interfere with the right side and destructively interfere with the left side. So this right side will be prevailing. And when we have this in an oscillatory fashion, we will have different different time steps of this constructive destructive evolution, and we will have something we can interpret as probability distribution moving forwards and backwards. Stop sharing, and then I just ask you on my behalf to show the sign, yes, meeting is done, everyone is welcome to depart and disconnect, and looking forward to see you on Wednesday. Many thanks to everyone for helping in leading this discussion. Thank you for your intellectual and energetic contributions.
Yes.
Yeah.
Yeah.